Welcome to MathGPT. Today, we're going to learn how to do stoichiometry calculations involving moles to liters conversions using the ideal gas law. We'll explore this through a real-world example of burning methane gas with oxygen at standard temperature and pressure, also known as STP. Let's start with the chemical equation for the combustion of methane. CH_4 plus 2O_2 yields CO_2 plus 2H_2O. This equation is balanced, which means it reflects the conservation of mass. Every 1 mole of CH_4 reacts with 2 moles of O_2 to produce 1 mole of CO_2 and 2 moles of H_2O. Suppose we want to find out how many liters of oxygen gas are needed at STP to completely combust 4 moles of methane gas. Remember, STP means standard temperature and pressure, 0 degrees Celsius and 1 atmosphere pressure. Let's calculate it. First, let's understand that the ratio of moles of methane to oxygen, according to the balanced equation, is 1 to 2. This implies for every 1 mole of methane, we'll need 2 moles of oxygen. Since we have 4 moles of methane, we'll need how many moles of oxygen gas? 8 moles of oxygen gas. Now, we'll convert from moles of oxygen to liters of oxygen using the ideal gas law. First, the ideal gas law in terms of moles and liters can be represented as volume V of a gas equals the number of moles N times the ideal gas constant R times temperature T divided by pressure P. V equals NR T divided by P. Let's apply the ideal gas law to calculate the volume of 8 moles of oxygen gas. R, the ideal gas constant, is 0.0821 liters atmosphere per mole Kelvin. At STP, temperature T is 273 Kelvin and pressure P is 1 atmosphere. Let's plug these values into the ideal gas law equation to find the volume of 8 moles of oxygen gas needed. Plugging in the values, we have volume V equals 8 moles times 0.0821 liters ATM per mole Kelvin times 273 Kelvin divided by 1 atmosphere. Simplifying this gives us the volume of oxygen, 178.8 liters. And that's how we find the volume of a gas needed for a chemical reaction using stoichiometry and the ideal gas law. With these principles, you can perform a variety of calculations involving gases in chemical reactions. Remember, always make sure your units agree and practice with different problems to gain confidence.